Good morning, dear primary 6 students of St. Joseph's International School. In this video, we continue explaining the science curriculum, and we are in concept 3, theme 1, talking about energy as a system. So, in the last video, we talked about how energy, some kinds of energy can be a system, and we talked about electricity, gravity, and magnetism. One of the last things that we talked about was electric conductors and insulators. So this is where we continue. In this activity, we have a few kinds of materials, such as a battery, a small LED lamp, any kind of lamp, wires, aluminum foil, electrical tape, coins, random materials. Okay, so what are we going to do now is we make a circuit and we leave it open in here. We have a battery, wires, the lamp, and this place is empty. Of course, we know that air is a bad conductor of electricity, an insulator. So electricity doesn't pass here. So what happens when we place different materials? What happens when we put the coin? It lights up. What happens when we put a rubber, an eraser? It doesn't light up. So this activity helps you to know more about conductors and insulators, and you can try solving this. So which ones are conductors and which ones are insulators? So the iron nail, is it a conductor or an insulator? Well, it's a conductor. A plastic spoon is an insulator. Rubber, insulator. Metallic spoon, a conductor. We said metals are good conductors of electricity. A piece of wood is an insulator, and a metallic key is a conductor. Good. So, moving on, we are trying now to make our own electric circuit. We said that we are talking about conductors and insulators, and we now supposedly understand them completely. We are going to talk about some other very important component of an electric circuit, which is a resistor. And resistors are components of an electric circuit that limit the flow of electric current. So that's the difference between a resistor and an insulator. An insulator stops the flow of electric current, but the resistor limits it. It decreases the flow, doesn't stop it. So that's why resistors are very important, because sometimes the energy in the battery is more than the device can take. And this will cause the device to blow up, to not work anymore. So the resistor limits the flow, limits the amount of energy going into the device to protect it, to avoid damage. And you can find resistors in toasters, in microwaves, in stoves. Stove is like the botagaz. So this resistor, this component, protects devices from damage because it decreases the flow of electric current, protecting the device. So now let's talk about something very important about electric circuits, which are the two kinds of electric circuits. They can be series or they can be parallel. Well, what's the difference? In a series circuit, all the components are connected in a single loop, in one path. in one way, and the electric current can only flow one path, and it has to move from one component to another. So it starts from the battery to the switch, to the wire, to the first device, wire, second device, and wire to the battery, and moving on and on and on. So this is how electricity moves in series circuits. But what about in parallel circuits? It can have two or more branches, two or more paths for electricity to move in, for the electric current to flow in. So let's see. It starts from the battery to the switch to the wires, but now it can move in this lamp and in this lamp at the same time, and back to the battery and doing the same over and over. But why do we do this? Well, let's say the lamp, this one, is burnt, is not working anymore. What happens to this one? It will not work as well, because now the circuit is open here. But in this case, this one is not working. That's okay. This one will work because electricity has another way to move in. It doesn't care about this one. So parallel circuits allow devices to not work at the same time. That's why almost all our devices at home are connected in parallel. Why? Why? Because when you turn off a lamp, all other devices at home, they don't turn off. They are still working. So the parallel circuit allows you to turn on and off as you please all the devices at home without thinking about other devices. So they continue to work. Good. And of course, when one house has a problem, of course not all the houses in the same building have the same problem. This is one very important reason to have parallel circuits as well. Good. Now let's talk about two ways of energy and mixing them together. Earlier we talked about the electromagnet, how to make a magnet using electricity. Now we are going to talk about how to generate electricity using a magnet. So first we get a device called a galvanometer. A galvanometer, it's a device that's used to detect, to tell if there is a flow of small electric currents or not. That's what we mean by detect, to see. So the galvanometer is connected to a wire, and this wire is coiled around a hollow tube. It doesn't have to be metallic this time. And when you move a magnet in and out of this tube quickly, you can see the pointer of the galvanometer working. So instead of the galvanometer, if you put in a device, a lamp here, you can see that it's lighting up due to the movement of the magnet. So this is how generators work, using a magnet and a coil, remember? So this is very important for something called the motor, the opposite of the generator. Remember, the generator converts mechanical energy into electrical energy. The motor is exactly the opposite. It converts electrical energy into mechanical or kinetic energy. An electric transformer transforms between different kinds of electricity, but this you don't have to care about now. You will study it in detail as you go older. So that's okay for now. Moving on to the last lesson of this concept, and we study a device that is helping humans when they have a disease in their heart, when they have a problem in their heart. So naturally, the heart is a muscle that beats continually. We know that from the last concept. And it does this for the whole duration of our life. And the heart, it has a natural pacemaker. What's a pacemaker? A regulator that makes it bump in a regular way, sending blood all over the body. But sometimes this natural pacemaker starts to fail and you don't beat regularly anymore. And this is of course a problem. So this is why we need an artificial pacemaker, and this is a device that has a battery, and this battery is this device is inserted into the chest and is connected to the heart, allowing the muscles of the heart to beat regularly as before. And this device has been in use for over 60 years now, so it's an easy operation and it's safe. It's not a big problem anymore. And to build a pacemaker, you need a battery, some insulated wires, and a motherboard to regulate the heartbeats, to give orders instead of like the brain. So a motherboard is the brain of any electrical device. In the future, we're trying to make them smaller and so they can be easier and safer for the body as well. And of course, it's a very easy surgery. It's not a big problem anymore because, as we have said, it's been in use for over 60 years. So that was all for concept 3 in theme 1, and that's the end of theme 1. Hopefully you have understood as much as possible, and you will understand more and you solve more questions. And of course, as usual, if you have any questions, you can ask your teacher or through the website. Best of luck and see you next time.